I want to warmly welcome you, new acquaintances and old friends, to join us at this debut. Vancouver Island has always been a very intriguing area. I was just talking to an old acquaintance, Bill Cook, meaning long time, long time. Vancouver Island has a reputation of always being able to come up with good companies that really are successful. So maybe the soil, maybe the people, maybe the water. So there's a lot of things for a lot of people to learn the secrets. I will be remiss if I do not thank the sponsor, one of the key sponsors for this event, Royal Road University. This is an excellent building and very fitting to start this particular event because of the all the very detailed consideration on energy conservation, on greenness, and on using renewable energy as much as possible, the smart way to apply them. So I don't know whether Charles is here. Charles, Professor Charles Kusakov. Please stand up. Let's give Charles a big hand. My colleague Tom McDowell has been very instrumental in making this happen. And I met Tom about a year ago. And since then, we have multiple conversations, and he has been given us a lot of wisdom and guidance. So please join me before we start this event in thanking Tom McDowell. So let's get started. I will give a brief introduction. For those who don't know me, my name is Elmer Sum. I'm the Managing Director of this Green Tech Exchange. And we started this about, I usually don't read the slides, so you can read it yourself, I'm sure. We started this about March of 2009 at the Simon Fraser University Vancouver campus, right downtown. And the reason we started it is because and I genuinely feel that this particular field, green tech, clean energy, renewable energy, sustainability, this sector is like the information technology 40 years ago. It is at the crust of growing very fast. And being one of the greenest place on earth in this region, we ought to be able to have a claim on this, say, hey, wait a minute, San Diego, wait a minute, Boston, wait a minute, London, wait a minute, Denmark. We are as good in a lot of this area. Now you see one of the slides there, I put down those big numbers. For those who may be interested, that's $1.7 trillion. I put out there particularly to grab your attention. I want us to be able collectively to be able to get part of those 1.7 trillion that will be spent by one country alone in this clean energy, green technologies area. Our research capabilities, our product solutions, our collective wisdom, our nature, the way that we manage this environment, all those people want to learn from us. And by ourselves, alone, whether it's Vancouver, Surrey, Victoria, Seattle, I don't think is enough to counter a lot of these external big boys. We must work together. And together we'll be able to grab not only part of that 1.7 trillion, but there are others that are looking to get some of our know-how and have our great institution to train their students and have our solution to be demonstrated in their area. So I'm confident if we work together well, we will be able to do that. So, Alan, you can just, by the way, both Alan and
Ellen. Dorothy is
Dorothy?
outside at the moment.
Okay, I'll introduce those two teammates who actually are the key spark plugs to make this happen. So I'll do that introduction. By the way, this very nice color QR code is done by one of the companies in our incubator. And they happen to be having this idea of having this color code for a individualized company and organization. So they were very kind to provide us with this. So I hope that if you're interested in that, then we will introduce you to them as well. Cultivate, collaborate, and grow. If nothing else you take away tonight, those are the 3 words that we hope that we'll be able to share together. I thank you very much again for joining us tonight, and I look forward to meeting every one of you either now or in the near future. Thank you very much. Now I want to turn the podium to my good friend and also my wise advisor on the Vancouver Island, Mr. Tom McDowell. Now, for those who may not know Tom, give a brief introduction to Tom. Tom is a very senior aircraft design engineer. And he's a Canadian, but worked extensively in Europe, in North America, and elsewhere. So, as I said, I only know Tom about a year, but we seem to have a very good rapport, and then we have been collaborating, and hopefully will extend the collaboration further as we move forward. Tom has been very keen and key in making today's debut happen. So Tom, thank you so much.
Pleasure.
Okay, Tom McDowell.
Thank you, Elmo. The reason why I'm having to use the microphone is now we're online, live stream video, and voice as well. So, yes, just another reminder. My name again, Tom McDowell, and I'm the Vancouver Island Coordinator for Green Tech Exchange. Very excited to be with you. It's been a challenging series of days and weeks, but very happy to be here and to see that we're also utilizing Royal Roads' new Innovation and Learning Center, as well as broadcasting, as I said, online. So it's very exciting. First, I have 3 broad points before I go into outlining the agenda tonight and introducing the speakers. The first is I want to personally extend a big thank you to everyone I've personally met. Several of you are here today. I recognize several faces. So I thank you for all your help the last 18 months or so. Several government focals, several business focals, not only on Vancouver Island, but also in Seattle and Vancouver, have been very instrumental in helping me navigate through all the little channels to get us to where we are tonight. So a big thank you. Secondly, I'd like to quickly describe what green tech is about. It's about using environmentally friendly processes for energy production. Instead of relying on traditional methods for like burning fossil fuels. So that's a quick overview of what green tech is all about. And thirdly, I'd like to now spend a bit of time outlining a few salient characteristics of Vancouver Island, mostly for the online audience. So bear with me, please. The island is the largest Pacific island east of New Zealand. and the population is about 750,000 people. It's Canada's second most populous island. The island sits about 20 to 40 kilometers west of Vancouver, and it parallels the mainland of BC. Half of the island's population reside in the southern region, Greater Victoria region on the island, and Victoria, the city of Victoria, is the capital city of British Columbia. Victoria is about 100 or so kilometers southwest of the city of Vancouver, and it's about 110 miles or so northwest of the city of Seattle. The island has got a fully integrated ferry, air and road transportation system, and it has a dynamic mix of young, mid-career and well-educated workers. The island, though, only generates about 25% of its energy. 75% of it comes from the mainland. That said, there are several green tech operations in place on the island. There is a solar-powered community just west of Victoria in the town of Souk. There is a well-established ocean research, ocean science center. In fact, the world's first seafloor observatory is just out to the west of the island. Neptune, Canada, for those who like to look it up later. It's already operational. It's relaying data to students and researchers worldwide, real-time via the web. Just to give you a sense of the dynamic workforce that's operating on the island. Secondly, Canada's first grid-connected tidal energy plant is soon to go in Campbell River. There is another pilot project out to the west in a town called Ucluelet on the west coast. The island also is host to the first municipal program to help businesses and homeowners switch to renewable energy here in Colwood, which is where we are tonight. There is several geothermal waste heat recovery operations in place, not only in the Greater Victoria area, but also in the Nanaimo, the mid-island region. So with that said, I'd like to take a few minutes to go through a bit of housekeeping. This event, as I said, is being recorded, and it's online as well. The agenda is as follows: 30 minutes of presentation time by our speakers, followed by a bit of Q&A, and we will also be entertaining questions online. So I urge those listening online to go and log in on the live stream feed and present your questions. They will be reviewed by our staff, and we will attempt to address them as soon as we can. Now on to, after the Q&A, we'll also be allowing everyone to mix and meet with the speakers as well. Hoping to close down approximately around 8-ish, but that's not fixed, okay? So now to our inaugural and main event presentation. Extremely honored to have Paul Manson and James Griffiths from Seabreeze Power Corporation here to enlighten us on wind energy production and transmission on Vancouver Island. James Griffiths, manager of wind development at Seabreeze Power, has played a key role in project design, environmental investigation, permitting, marketing, and equity financing of the Cape Scott wind farm near Port Hardy. He also completed his master's in environment and management here at Royal Roads. So welcome back, James. Paul Manson, president and CEO of Seabreeze Power, leads a dynamic team of professionals dedicated to the development of renewable power generation sites, including several projects here on Vancouver Island. Through a joint venture, Paul spearheads the development of high voltage transmission projects designed to support rapid advancement of the age of renewables. Ladies and gentlemen, please welcome our first speaker, James Griffiths.
So, thanks, Elmer, and thanks everyone for having me here. Can you hear me okay? All right. Let's say I've got 10 minutes, so I'll try to do this in 10 minutes, and that way we can have some Q&A. Hopefully we can have a bit of discussion afterwards as well. So thanks, it's a tremendous honor to be here. Hello to everyone online as well, in your pajamas, I hope you're comfortable. Ellen also asked me to remind you all that you can download this talk later in case you're someone that likes to watch the same movie twice. You can see it all over again. So yes, it's a great honor to be back here. I did go to school here at Royal Roads. I did a master's in environment and management, learned a whole lot from my profs, perhaps even more from my classmates here, and that was really cool. Our office at Seabreeze, we're a wind power developer primarily, and we also have a transmission branch. Our office is downtown in Vancouver, but I was born here in Victoria, so it's good to be back. And so I've been working at Seabreeze for 10 years, developing wind power projects, primarily the Cape Scott wind farm that I'll be telling you about. I also, just in my spare time, I like to go sailing. I like to play the trumpet in a really cool community band in Vancouver. So I like to do wind-powered activities. That's sort of a theme for me. And good. So let's get started. Real quick, what we'll talk about today, a bit about the investigations we've been doing into wind power here on Vancouver Island, mostly. An overview on the Cape Scott wind farm project, a bit of a status of where it's at and some next steps. And I'll talk a little bit about the future for prospects for wind development here on Vancouver Island. So Seabreeze has about 12 sites we're investigating, mostly on the northern part of the island, sort of centered up near Port Hardy, Port McNeill. What we hold is investigative use permits, so that's the rights to investigate an area. And we have roughly 15 meteorological towers. These are towers maybe 50, 60, up to 80 meters that measure the wind at various levels. It's quite an investment, and we need to be quite careful about it because most sites that one investigates do not actually go ahead and get built. There are other companies in the area as well. There's at least 3, 4, 5 other companies that have similar permits, and it's a whole game in prospecting where the winds are. You hear anecdotal evidence. There are some publicly available maps, but really until you go and measure on the site, specifically, especially in BC, like it's really a challenge in BC with complex terrain. Very, very site-specific to find the resource. So that's been a lot of work. The total resource has been estimated. There's this report here from Gurad Hassan in 2008. They actually estimated about 6,000 megawatts, but they thought about 600 of it could actually be built, given all the constraints. So it's a good place for the resource. It's also a great place in terms of local infrastructure and skilled labor, particularly forestry and mining, whole lot of skilled folks. And frankly, the economy has been suffering up there. So there's folks who would like work. Our project is located approximately 35 kilometers. It's not east of Port Hardy. That would be in the water. West of Port Hardy. It's an elevated plateau. It's actually a really, really neat ecosystem. It's primarily a bog. It's a big blanket wetland and a sort of bog and bog forest. It's something that's globally quite rare, but occurs a lot on the BC coast from this point north. You'll find it up the coast. As I mentioned, we've been developing here for 10 years. 8 meteorological towers are here on the site. And that was necessary just because there is some topography to really map out which part of the site would be the windiest. It's about a 4,500 hectare site that we've been studying that, and we've permitted over the years through the environmental assessment process and some other permitting. That said, only about 5 to 7% of that area typically gets built with a wind farm. So in here, it is a sensitive ecosystem. It needs to be done well, but it will leave the vast majority of that wetland still functioning as wetland. That's why typically wind farms are good neighbors in the landscape. They work well with farms and other types of activities that they don't displace. This project does require a 40-kilometer transmission line to Port Hardy, so that's a part of our project. And it's in the shared territory of the Quagith First Nation, the Tlatlasikula, and the Quatsino First Nation. Some advantages of this site, and you can see the photo here. It's really quite beautiful. This is going to be the most beautiful wind farm in the world. That's my opinion. Other people have different opinions. Really cool spot. Lots of bonsai trees, really stunted, and you really get a feeling that it's not a high productivity ecosystem up there. The water really doesn't flow. It's really stagnant. It doesn't drain well, and so really low sort of ecological productivity. It's not a high value spot for a lot of wildlife. And you really find when it comes to environmental, ecological impacts of a wind farm, siting is a huge deal. So we really think this is an appropriate site, and we take that pretty seriously. It's also far from residents, no one up there. There's a small town of Holberg that's about 5 or 8 kilometers away, and Port Hardy's 35k away. So it's really not bothering anyone up there. We've had extremely strong support from the public. Our meetings are fun to attend. People show up, they want work, they're very interested. Also strong support from local governments. And the 3 First Nations I mentioned have been extremely supportive and are actually a partner on the project as well. I mentioned it's environmentally appropriate, well-researched. Transmission capacity is another key. I mentioned there may be a resource there, but it's important to get that resource to market. So there is transmission capacity, and I'll come back to this, because as I say on the slide, there may not be transmission capacity anymore once we're done. Sorry about that. We sized the project to take up roughly the capacity we thought would be available on this line, and we'll see a map of it, given the other stuff that was up and running on the line, and another hydro project that's going in near Port McNeill called the Kokish project. Wow. Well, ambiance. Thank you. So the project, we've been working on it for 10 years. Tremendously fortunate, but hopefully also due to our good work, we received an electricity purchase agreement from BC Hydro in 2010. This is probably the key milestone for a wind farm, other than actually commercial operation. So you can do all the work you want and put all this high-risk investment into a site until you get a contract with someone, and around here it's got to be BC Hydro pretty much, to sell that product. You still aren't guaranteed to have success. So tremendously fortunate. There are 3 wind farms operating in BC today. They're all up in the northeast. And in the last round there were 6 contracts. I think there were 19 wind bidders, and 6 of them got contracts. So we're quite fortunate to be one of those, and we're the only one that's not in the Peace region. Hopefully this, and I'm very confident this project will get built, and it'll be the first large wind farm on Vancouver Island. So it was great to hit that milestone, but we found, we're a small startup operation in Vancouver, and we simply are not able to raise the $100 million of equity to get this project done. We found that the way forward was to sell the project. So we've sold the first phase, the 99 megawatt first phase that has that contract, to a company called IPR JDF Suez. They're not that proud of the name either, but it's a big merger between some very successful utilities and independent power producers. Sold to them. We retain the rights to a minority ownership, so we're pretty excited about that. And that means that we stay involved in the project, and there'll be a lot of learning that we hope to do in this project that we can apply to future ones. The turbines that were selected was one that we were looking at, and the partner made the final choice. So there'll be 55 of these things. It's the Vestas V90. Vestas has been traditionally the market leader in wind turbines globally. They're a Danish company with operations all over. These turbines have an 80-meter hub height, about 250 feet, and that's 125 if you go to the top of the blade. And I'll show you some photos in a bit, but that rotor there, you can see the 3 blades, that's bigger than a 747, spinning up in the air, times 55. So pretty tremendous, and I really do look forward to stepping foot up there and seeing these things. Slated to begin construction very soon, just waiting on the completion of the federal permitting, and should be in operation in early 2013, roughly a 12 to 16 month construction period. So after all the work it takes to plan these things, they really can go up really quick. Just real quickly, the layout. We found the windiest areas, the most constructible areas were there on the west part of the site. So everything in the green there, and this is a map that the 2 of us worked together on in our environmental assessment, that will be that phase 1. And everything over on the east side will it'll remain with Seabreeze, and we can bid that to BC Hydro next time around. Some of the economic benefits really quickly. Capital cost of over $300 million. We estimate about $50 million of that will be spent in BC, much of that on the island. There'll be about 80 construction jobs over that 12-16 month period, and perhaps equally important, about a dozen long-term jobs over 20 years. And a lot of folks up there find that very interesting. Those will be good green jobs. Also a bunch of tax revenue. That's a benefit to the island. I figure the government's on the island, right? So about $500,000 a year in tax revenue, land lease fees, income taxes. And also the First Nations, I mentioned they're a partner in the project. So they'll have some benefit. They'll have some participation in the project as well. And they're excited about that. Okay, so for the future, that's my 10 minutes. I'll move forward. Charles, that we recognized earlier, he was my economics prof here at Royal Roads. And I don't remember all of it, but I remember something about supply and demand. So I'll go through that real quick. So the supply for this type of stuff in BC is typically a wind farm or other kind of renewable power developed by an independent power producer like ourselves. They come online according to a cost curve. So we would bid first, the cheapest sites that we felt we could successfully build, and then, as those get built, perhaps it'll go along the cost curve. There are other non-cost factors, risks, environmental concerns, social concerns, all kinds of stuff we probably haven't thought up yet that can affect a project. Also, technological advances can definitely make projects more feasible as time goes on. And then there's a question of how much of the power that gets built is wind versus other fuels. That's also a technology question. Our capital cost is probably 70% that wind turbine. And so as those projects, as those efficiencies change, as those costs change, can really affect our competitiveness versus something like small hydro. And then there's regional transmission constraints I'll get at in a second. Then on the demand side, traditionally it's been discrete calls for power. BC Hydro has said there's a bidding process. We'd like roughly this much power. They receive typically several times the amount, and then they pick from that, and they pick their favorites. And that depends on their projection of low growth, trying to meet that growth, perhaps depending on the policy of the day, having a bit extra insurance beyond that low growth, and perhaps also wanting power to export into other jurisdictions that may not have the resources we have. There are some other ways. Something called the Standing Offer Program is a great program for smaller, up to 15 megawatt projects. A little more expensive at that size. Wind likes to be typically around 100 megawatts, but that's a way. And then it is possible that there could be buyers other than BC Hydro. No one's made that work yet in BC, but it's worth looking at. So that's commentary in general about the future for something like wind power. On the island, I mentioned this transmission line. So we'll be connecting, if you can see it, that PHY up at the top. That's Port Hardy Substation. And that blue line that comes all the way down to Gold River, it pairs up with a green line, and it goes to where you see the first red line at Dunsmuir and over to the mainland. That's the strong point. That whole blue line down there at some point needs to be upgraded. So our project and the hydro project nearby will take up most of that line. And the communities up on the North Island I mentioned are quite supportive. They've organized over the years a lot of effort to try to bring some support to the idea of a transmission upgrade here. There is more potential up there. And if this line can be upgraded, there can be more projects come online. So the question of whether there will be more wind power on Vancouver Island and the resources primarily in the north really depends on the upgrade of this line. I'm past my 10 minutes. I couldn't help myself. I want to show you some really cool construction photos really fast. That's a tower base several meters across. Tower is usually several sections. Tubular steel, a couple inches thick. They're put up by cranes that can lift 500 tons. They only actually lift 100 tons, but they need to lift them out at a distance. And so it needs to be quite a strong crane, and it needs to move around the site. So just to go back here, that's a nacelle in the background, what we're accelerating here. Here we go. That's a nacelle in the background. That weighs about 100 tons, so that's the generator. Here's a crane putting up parts of the tower. Having trouble with my slides.
Oh.
Here we go. 2 nacelles, again, about 100 tons. They come in on trucks. If you're in Nanaimo or north of Nanaimo, starting, I don't know, maybe June, you might see these things. Each turbine, 55 of them, takes more than a dozen truckloads worth of equipment, so there'll be quite a lot coming through Duke Point. That's the blade. Feels a lot like a sailboat made of fiberglass, really flexible, roughly 45 meters long. Lifted very carefully by cranes. Here we go. Often one by one and put up onto the turbine. Here we go. So that's the nacelles lifted up, lifting the blades one by one. That's about it. I hope we have time for questions. I hope we have time for discussion. I understand we're going to have my boss, Paul Manson, come and speak next, and then we'll have some questions after that. Thank you.
Thank you, James. I'd just like to pause for a few minutes, or a few seconds really, just to allow some students to come in. If we could just make some room for the students hanging out the back there. maybe one is not a student, sorry. So if we could just make some space, pull them in, because they've been very patient. Thank you so much. Paul Manson, Seabreeze Power.
Thanks, Tom. It's a real pleasure to be here this evening. Just a few words about my own background. When I was 18 years old, I hitchhiked out here from the East Coast where I had grown up to the village of Ucluelet, where I got work on a trawler and ended up in the fishing business for the next 16 years. But I do have to say that within hours of reaching the west coast of Vancouver Island, I had fallen in love with the place. And that this Vancouver Island has remained a special place to me for all these years. I spent a good deal of time on the north coast of British Columbia and a lot of, in fact, the whole coast of British Columbia. And it was largely through that experience that eventually, about 10 years ago, I reached the realization with a friend of mine that British Columbia would probably be an ideal place to be developing wind power. And so we started a company called Seabreeze Energy. But it was not without a great deal of soul searching for a couple of months, because having grown up in Manhattan, I recognized what a special place the coast of British Columbia was. And I think the balancing act that I finally resolved in my own mind was that with the resource that we had here, and as I've learned over the years, not just with wind, but with other types of renewables, truly a world-class resource, that responsible development of energy generation on the scale that we're proposing, done responsibly, it will change this coast, but somewhere these changes have to occur. And I guess just to sort of summarize three great pleasures that I have had in this period of time in this line of work. First is finding a career for myself in renewable energy. Second is being able to help create opportunities for younger people to build their careers in this area. And thirdly is a rather extraordinary opportunity of learning about the First Nations of this coast and the realization that we so often have two solitudes, and there's an enormous potential for collaboration going forward. So that being said, I am president of Seabreeze Power, but I'm really going to be speaking about a project which is a joint venture, the Wanda Fuca Cable. May need some help on this. Thanks. So just in summary, the Wanda Fuca Cable is a proposed link between Greater Victoria and Port Angeles in Washington State, 550 megawatts, 150 kV, and a distance of around 50 kilometers, and which is around 30 miles. Two-thirds of that is undersea. Whoops, I'm sorry. It's important to recognize that the city of Victoria is at the end of a long radial system coming down from the Duncan Ladysmith area, and that Port Angeles as well is a transmission line coming up from Olympia to Port Angeles, which means that both of these communities, regions, really only have electricity coming to them from one direction. And what the advantage of, or one advantage that the Wanda Fuca Cable will bring in connecting these points is that it creates a second source of electricity for each of these regions, thereby improving the reliability.
Oops.
Well, we're going to go through this pretty quickly.
Why this is happening? Ah. Okay, it's not even stopping. Okay, hold on everybody, sorry about that.
These are the glitches of the inaugural event.
If you tell me, I can change the slides.
Oh, okay. Okay, yeah, if you could click it again, please. Yeah, okay, and it's the next one. Whoa.
Oh. Yes.
Actually,
The one you want?
well, yeah, that's good.
Okay.
It's not showing up on this screen, but I'll just work off the. So the technology that we have selected for this this project is really 21st century quality. It's direct current, it's fast, it's responsive. It basically will form the backbone of what is often referred to as smart grid. And it's very well suited for automated use. By the time it takes you to look at your watch, the full power capacity of this cable can reverse 120 times. It's being used a lot in Europe now for offshore sites, and it's especially good for tying new generation into very weak points of the grid. Right now in Northern Europe, there's 3,500 megawatts of offshore generation, which has been tied in with HVDC. VSC stands for voltage source control technology. And there's another 3,000 megawatts scheduled over the next couple of years. This is technology which, over the last 15 years, the voltage source conversion technology, or also known as HVDC Light by ABB, HVDC Plus by Siemens, is really gained a lot of respect for its reliability. One of the North Sea gas platforms selected it for compression, and literally 15% of Europe's natural gas supply now relies on this this one gas line, electric cable. This is just a map showing locations of HVDC technology throughout Europe. ABB had been the original pioneer with this technology. Brief history of this. Really in 1954 was the first major commercial installation between Stockholm and the island of Gotland in the Baltic. And in the mid-90s, the voltage source conversion model of this technology came out, and now it's really spreading throughout the world. In addition to Siemens and ABB, in the last couple of years, Areva and some of the Chinese manufacturers have started to produce it. Next slide. So I mentioned that we have control of directional flow with this. There's voltage and frequency stability. Just a word on this. You may recall several years ago during the Thanksgiving Day there was an outage in Victoria that I understand was caused by harmonics further up island. And the voltage and frequency stability, which the conversion terminals of the HVDC light technology would solve that problem. And at the same time, had a cable like this been in place, you wouldn't have had an outage, because with problems, if there were any up island, you can always get it from down south. Black start capability is an ability to hold a charge and the ability to bring a system up more easily than the AC systems. Often when there's an outage, you may notice the lights sort of come on, they flicker, and then they go off again. It's the engineers trying to often manually balance the system coming up. What we're really talking about is an automated process here where things can be done smoothly and with safety. VARS is a bit of an esoteric term. It basically is it's a way of stabilizing power flows. This is quite a large expense of the utilities, but it comes as a byproduct with this new technology. Ride-through capability is another technical benefit that comes just as a function of the technology. Of interest to me is some of the environmental aspects of HVDC light. It's an HVDC generally free of fluctuating electromagnetic fields. It can be buried at a reasonable cost, unlike AC. A rule of thumb with AC, if you want to bury AC, it's going to be 5 to 10 times the cost of an overhead line. If you're going to be putting DC underground, it's more or less akin to laying a PVC pipe. And so it will still be more expensive than overhead, but not into the order of magnitude as overhead AC. So if you're burying a PVC pipe, obviously you don't need a very wide right-of-way. This reduces the land use problems, reduces the amount of herbicides that have to be used to maintain a right-of-way. And I think on the next, I think I have another slide talking about this carbon impact. This table is a comparison between an AC overhead line and a DC underground line, and it shows the material consumed per meter with these two different ways of handling a transmission project. And it's just extraordinary to me the less material which is consumed, but with that, if you go back to the other slide, because so much of an overhead line consists of the steel towers and the concrete footings, these are very, very carbon-intensive materials. And you end up with 17% in this calculation of the carbon impact of a DC line versus an AC overhead line. Another very important factor here is that because the DC does not have fluctuating electromagnetic fields and it can be sited underground, these are the two major points of opposition which the public generally has, concerns that they have around transmission projects. And consequently, permitting becomes one of the major challenges in putting in a new transmission line. Believe me, we really need new transmission. It was about a 30-year period from the late 70s until just the last couple of years where there were only a handful, literally, of new transmission lines built throughout North America. So not only is the infrastructure aging, but we have new requirements for hooking up new sources of renewables and so on. So the urgency for transmission is becoming acute in different parts of North America. Now, if you can reduce the permitting period that it takes from perhaps 5 to 7 years to perhaps 2 to 3 years, you see, you can begin to integrate the planning process of the transmission requirements with the generation requirements. Right now, you can plan a generation program, and you could conceivably have it built in 3 or 4 years, but if the transmission isn't there, you're stuck for another 5 years until the transmission is put into place. In marine settings, HVDC technology is made of a solid materials in the cable. It doesn't require the coolants in a marine setting that most AC cables require. Those AC cables over time will invariably begin to leak out the coolants. They're oil-based, and it's one of the dirty secrets of the electricity industry as to what's constantly being pumped into the ocean to keep those underground cables around the world cool. What we do with the installation of these cables is we drill a tunnel about a foot wide in diameter, several hundred feet back from the shore to a depth beneath the intertidal zone, and thereby we ensure that there's absolutely no disturbance to the sensitive marine intertidal zone. So all in all, this is an excellent technology for British Columbia's coast, where high voltage transmission is required. Next slide, please. Just in brief, we have received all of the major permits on both sides of the border. We'll be up for renewal with the Certificate of Public Convenience and Necessity, but we have gone through this process. I think we've adequately demonstrated that that there's absolutely minimal environmental impacts. In fact, similar cable on the East Coast between New Jersey and New York went through the permitting process. It's been in operation now for several years. No negative interveners. The process, the public hearing that we had here for the Juan de Fuca cable, there's a group of fishermen that were concerned legitimately perhaps about snagging gear on the underground cable, but this is, this is easily mitigated. There was another concern that heat emitted from the cable would cause the vegetation growing above it to have a different color or different characteristics. And again, this is small problems compared to the objections that are often raised with transmission permitting. On the technical side, there's a suite of studies which have to be done to ensure that a transmission interconnection is not going to cause major problems to the rest of the system. And we've gone through all of these steps, and there's been found no negative impacts to either the U.S. or the Canadian system. And we're just in the final stage of what's called a path rating process, which would allow the full 550 megawatts to be utilized. What we still need, and I would say arguably the main reason why this project has not yet gone ahead, are the commercial arrangements that have to be in place with BC Hydro and Bonneville Power Administration in the U.S. And once we can arrive at suitable arrangements, we can then finalize what's called the EPC, or the Engineering, Procurement, and Construction contract, likely with ABB for installation of the cable. So, let me go back a slide. So, I think a common misunderstanding for those people who have been following this project for a number of years now is a misplaced assumption that this is really just an interconnection between Victoria and Port Angeles. Presently, there's 2 interconnections between the U.S. high voltage, and really right now nothing else over to Manitoba. Of these 2 interconnections, 90% is along the I-5 corridor, around 10% of the traffic between Nelson and Spokane. And what the Juan de Fuca cable would do is add a third pathway to the general Canadian American intertie. Next slide. Thanks. By expanding this capacity and by allowing more north-south traffic, I should point out that the Seattle-Vancouver pathway is quite congested. It's one of the most congested in North America. Would allow power which is owned by British Columbia. It's generated in the U.S., but it's owned by British Columbia on account of dams that were built on the Canadian side of the Columbia River to help regulate the flows on the U.S. side and optimize the generation there. We own around 1,100 megawatts of production out of Washington State. For decades, it's just been sold into the market down in Portland. But 9 out of the last 10 years, British Columbia has been a net importer of energy. And as we're talking about economic expansion and industrial growth in the north, this downstream benefits power is I think, a very valid source to look at for helping to support that economic growth. Another very fascinating aspect of what more expansion between British Columbia and the Northwest can do is that we have very, very different wind regimes. Along the West Coast, this graph shows winter peaking, and the blue graph shows the annual power generation out of the Columbia Gorge region. Well, if you can combine these resources, you end up with what begins to replicate base power generation. And this means that each region individually otherwise would have to be looking at the large dams or natural gas plants to do what's called firming the resource, which essentially means making it dispatchable so that when you put on the switch, it's there. So what the concept here is that we can now use renewables to firm renewables. But the only way to capture this value is with additional transmission capacity. It's also worth noting that with regards to the energy requirements south of the border, the probability of the wind blowing at a good clip during the hours when energy is most needed is 4 times that of 4 times from British Columbia, from the coast of British Columbia, of the power which is generated in the Columbia Gorge. And so this in turn creates an opportunity. If we have more capacity for transmission, this is potentially another long-term market for British Columbia, especially as we move above the 20 and 33% present levels that are generally being talked about. As we move into higher percentages of renewables penetration, there will be increasing demand. We can help to fill that. Briefly on financing, this is a project which would cost itself around $500 million. We've budgeted, in addition to the capital costs of the project, $75 million on each side of the border to strengthen the transmission system to accommodate the full 550 megawatt flow right from the Chikai-Dunsmuir line towards Campbell River right down to Olympia, Washington. We are probably going to be using a conventional project financing approach with this, similar to a mortgage, put down a quarter of the money. We have an equity partner willing to step in as soon as we have agreements with the utilities. The balance would come from senior debt. Now we have come up with, I think, an extremely creative method for the financing of this. We're not looking for this simply to be paid for by the ratepayers or by the taxpayers of either British Columbia or the U.S. What we're proposing is a revenue sharing agreement with the utilities. And in essence, what this means is that every time power crosses the border, each of the utilities receives a fee from the person using the transmission line. And when you aggregate the new revenue, which is created by the new cross-border capacity, more trades are possible, enough new marginal revenue is generated to cover the cost of the debt and the return on equity on the project. Now I have another slide here which is a bit of an experiment, but hopefully we'll go through a couple of frames here and I'll explain it. So what's happening initially, maybe you go back one. Okay, so without the Wanda-Fuca cable, what we're seeing here is each utility is receiving payment for the use of the grid. With the next frame, Wanda-Fuca comes in and the utilities are receiving more money, all of which comes to the Wanda-Fuca Cable Company up to a certain level. And once that level is reached, the new money is shared between the Wanda-Fuca Cable Company and the utilities. So rather than being a cost to the utilities, this is actually a profit opportunity for both Bonneville and BC Hydro. This, I should really stress, is it's a radically new, and I'm proud to use the word radical in this case, radically new concept in terms of cost allocation for new transmission. So as I just mentioned, under this revenue sharing proposal, there would be no risk to BC Hydro or to its ratepayers, no risk to the taxpayers, and all of the risk is borne by the equity investor who has to be assured that there will be this new business created or allowed by the expansion of the transmission capacity. So just to summarize, we have more cross-border transmission capacity, translates into expanded trade opportunities for PowerX. The new infrastructure is paid for by the market without the financial risk being borne by the province. Access to low-cost energy out of the Pacific Northwest for a new and existing industrial load. Over-generation power is a regrettable situation in the Northwest right now, where for several months of the year they have put in so many thousands of new megawatts of wind energy in the Columbia Gorge that they can't manage it very well. And that power is literally being given away, or they're actually paying people to take that power at certain times of the year. This is tremendous opportunity for British Columbia to use integration through the reservoir system here for that power, which otherwise is can be going to waste. I mentioned the downstream benefits coming up the Wandafuka Cable. It's a energy source for Vancouver Island, and if Vancouver Island doesn't need it, backflow, counterflow to the mainland. Reliability, access to U.S. markets for export by independent power producers. So many benefits here, I needed 2 pages. I mentioned firming of renewables by renewables, relief of congestion, insurance against delays in other projects by allowing power to come in from new directions. National security, it's a new pathway in the event of seismic disturbances. Black Start, job creation. There was an independent study done by the Pacific Northwest Economic Region 2 or 3 years ago, which analyzed what the economic benefits of different transmission projects could bring to the regions in which they were operating. They came up with a number which staggered me. $134 billion for the Wandafuka Cable, 177,000 person years of employment. Now, this was done by Idaho National Labs. Just happy to provide the report to anyone, but it's an amazing number. And I guess the last point is that the choice of technology, these are projects which are going to have a life probably of 50, 75 years. If we can go by any of the history of the infrastructure which has been put in. And the choice of technology is absolutely vital. Huge capital expense. The decisions that we're making now, next couple of generations are going to be living with. And I think that we have identified a very, very viable solution for helping to support growth of renewables on Vancouver Island and the mainland. So thank you very much.
Thank you, Paul. Very solid and insightful presentation. James, Paul, please come to the stage, yes. And we're now opening the discussion to the audience and online members. Please, if you can, it's cozy in here, I know, so please, if you can, go to the mic. Otherwise, feel free just to stand up where you are and state your question, maybe your association as well, if you like, and we'll get some answers.
Hello. Great presentations, you guys. I want to focus back on James's presentation, which also was very good. Just let me frame it up here for a sec, because I've got a big question for you. So the wetlands that that the wind power energy is going to be built in, you're mentioning how they were low productivity, but yet sensitive ecosystems. The wetlands do flow, and that water will need to flow to maintain the ecosystem services that are there on the North Island. The road network is a big concern, right? The machinery that you showed on the pictures, the slides, is massive, right? So those pictures don't match what the wetland is. You know, those pictures are brownfields or open areas. And so my question is, in light of the sensitivity and the natural features that are there, as a green tech company, are you concerned about the perception if there are environmental impacts?
Go for it.
Just speak up. There's another.
Right. You all hear me? What's this? That's on? Okay. So thanks, Tyler. And Tyler's a former classmate of mine, also at Royal Roads. Did his master's thesis work on the habitat of the sandhill crane in and about the Cape Scott wind farm area and a bit to the north. So he doesn't know what he's asking about. And a good set of questions. So first of all, and maybe I wasn't clear enough, the photos I showed, of course, our project is not yet built. So those photos are from a site in Washington State called the Wild Horse Wind Farm that we were fortunate enough, we were invited to go on a tour during construction. So the equipment side is the same. Once you have your road network, equipment comes in, very little impact associated with sort of bringing the equipment in and installing it. Tyler's entirely right. It's the road network, especially in the case of our wind farm, that has most of the footprint impact and the potential to impact the wetland. And Tyler's also right that it's the flow of, with respect specifically to the integrity of the wetland ecosystem, it's a flow of water through that wetland. It flows very slowly. It's often very difficult to tell exactly which way it is flowing because it's kind of undulating. So that's something that was important when we did the environmental assessment work here, which we did in 2004 and have just had to redo some of it because of some changes to design. And I mean, the rule of thumb is to allow the water to flow through the road base. Tyler's also entirely correct that it would be, I think, irresponsible, as a company, and also detrimental to the image that we have in our social license to operate and build these types of projects in BC if we were to cause permanent damage to a wetland that's taken thousands and thousands of years to build up. So we did consult experts in hydrology. We consulted experts in Europe, in Ireland, where there's a case where there had been construction in about a wetland. We've seen what had been done in cases where it went well, what had been done wrong, and really came up with commitments that are now contractual commitments in the environmental assessment certificate around the way of building the road, having culverts come through the road, using large crushed rock that water can flow through in the road base, minimizing the width of the roads just to what's necessary, trying to keep the roads on the higher land, and then there's a series of environmental monitoring commitments as well. So we were able to convince the scientists that we hired, which have their own professional integrity, but they're working for us as well. We're able to convince the government agents, and they all agreed that the impacts we predicted are likely the ones we're going to see, and we have commitments to monitor them. That said, it's not built yet, and as with any project, there are going to be impacts. I think the question at the end of the day is whether those impacts are warranted given the benefits of this project, and we all felt that they were. So I think that's the most thorough answer I can give. And
thanks, James. That's good.
Yeah, thank you, Tyler. And we'll see as the monitoring comes in over the next few years as well.
Just quickly repeating that question for the online members. The question was about migrating birds, cranes, and such. So could you talk about that?
Yeah, for sure, and good question. So that's probably the other most important impact. With a wind farm, it all depends on the siting, but it's one that typically does come up. It's one, as opposed to most features on the landscape, we can tell from looking at the ground what kind of ecosystem that is. It's hard to tell immediately what type of airborne wildlife might be passing through. So with this site, there's not a whole lot of productivity. There's not a whole lot of food growing on this site. It's not the kind of place that migratory birds want to come in and land en masse and feed and fatten up on their journey. There are two species of concern that are mentioned in our environmental assessment. So one's a marble murrelet, and it's a seabird that it nests in old growth trees on land. So it makes that passage. And it's particularly large old growth trees with big branches with big sort of mossy shells on them. That's my understanding. And so from the photos you did see of the Cape Scott site, there aren't those types of trees where we're building the wind farm. That said, we did, the best tool is to use radar to track these birds. And so we did a number of years of radar studies with a biologist quite well respected. And he found in general that the birds are not flying up and over the site, they're flying through the valleys predominantly, and they're getting at those trees. That said, similar to my answer to Tyler, we predicted a level of impact that was not expected to have a population level effect, and then they'll be monitoring around that. Sandhill crane, similar situation of having done studies on them. Tyler's study is part of the science that's out there as well. With the sandhill crane, I think it was nesting that was the highest concern, and you can also talk to Tyler after. He probably knows more about the species than I do. But we have commitments around what part of the project we can construct and when. So when there's nests that are active, we simply can't be building around those nests or blasting around those nests or clearing around those nests during that period. So that's a major kind of mitigation we took on. And just to comment about the environmental assessment process, it's sometimes misunderstood. I don't think it should be seen as a pass or fail, whether your project is good enough to pass. You can fail. They can say at the end of the day that the impacts are not warranted. But it's a really good forum for bringing in all the voices together and identifying mitigation measures that really have a valuable effect. So in that case, it's those types of constraints and restrictions that we took on through dialogue with all the experts involved that I think will have a big impact.
I just make a comment.
Good evening. Dwayne Hart. I just moved down here from the Peace region, and I've had the honor to work with all the wind farms up in the Peace. And it's a great technology and works very well. I just want to salute you guys for bringing wind energy to Vancouver Island and also your transmission line. I think, just listening to these environmental questions, what a lot of people in British Columbia don't realize is that every evening we shut off our dams and we buy dirty coal power from Alberta. So by going to the wind farms and such, we can turn off these coal-powered plants in Alberta and start producing our own power that's clean, green, and environmentally friendly. Thank you.
So,
I noticed you mentioned one type of wind turbine and tower. Are you looking at only one type, or are there others? And which manufacturer would they be on the basis of safety and numbers?
Yeah, good question. With this site, it ended up going with Vestas, which is a very tried and tested machine. Over the years, wind on this continent, wind power got big in the 80s. And you saw a whole lot of technological divergence, people trying different types of designs. And then it really converged on that type of design we saw. It's typically called the Danish design. There's a tower, the rotor is upwind, there's 3 blades. They look very much the same. That said, the mechanics, the electrical side, what's inside is often quite different, and there's a lot of advances taking place in that area. There have typically been roughly a handful of companies that were the tried and tested ones, Vestas one of them. But these days, because the market got so hot, particularly pre-2008 crash, but even now, a lot of demand for wind power. It's been growing incredibly around the world, and it has become quite a mainstream type of power. So there's a lot of new companies have come online. And one trend now is that some developers or more so the owners of projects, the financiers, are willing to go with some of these new market entrants and give them a shot. And over time, they'll develop a track record. Keep in mind, too, I mean, our project has a 20-year contract to deliver. You know, the expected lifetime is expected to be at least 20 years. None of these technologies are actually 20 years old. So they really have to rely on you know, materials testing and failure testing and the ability to do maintenance in an efficient way. As all these things improve, you know, there'll be more and more competition in that area. With this project, we picked a safe turbine to design our project and bid it, but it was actually at the end of the day when we sold it to the new owner, we left that door open for them in case they had a favorite party, or you know, just make sure that they could make that choice. Does that answer your question?
Yes, in part. I've just heard that there, in some units, there have been fires and damages, and there are some companies that have fewer moving parts, and without mentioning any names there. But,
fewer moving parts is a good thing. The gearbox is typically a very expensive machine to fail, a component. So those turbines, and this Vestas one does have a gearbox. So the rotor spins, you know, roughly this fast, I think 17 RPM, but the actual generator is stepped up to a real fast clip. Some of the turbines don't have a gearbox. You know, it's that direct speed that goes into the generator. They'll certainly fail less. Fires are very rare. All kinds of mechanical failure, and they certainly happen, but they're extremely rare. There was a case in Denmark a while back. They had a huge storm come through, and we saw photos later. It took out entire forests, and the turbines are still standing. So it's not seen as, of all the risks we have to deal with, it's not one of the major ones, I think.
Okay, Mike?
Mike McWilliam, University of Victoria. I saw that the second phase there seems to be constrained by the grid capacity in the northern part of the island. So I wanted to hear from you guys where you are looking to maybe see the upgrades in the grid. Are you guys going to be installing your own extensions to the grid, or are you trying to push BC Hydro?
The word that we've had from BC Hydro is that there's around 140 megawatts of capacity available from Port Hardy down to Gold River, which is the next major substation. We strategically decided to bid roughly 100 megawatts on the Cape Scott project to allow other IPPs to come in and bid as well, on the logic that for future upgrades, which have to be agreed to by BC Hydro, that more voices were better than one from the region. I understand, but I can't say with certainty, that in the good old days, there was a philosophy known as building in advance of need. And I believe that the pathway between Gold River and Port Hardy is actually conductored to 230 megawatts capacity, or kV, but transformers were put in, which is one of the expensive components, which only allowed right now 140 megawatts. So it may be that by swapping out the old transformers, which are probably getting close to the end of their useful life now anyway, that we can economically see that capacity raised and probably allow another 100, maybe another 150 megawatts to be installed on the north end without much more expensive upgrades.
So,
the state of play of wind power today, is it viable economically, or do you still need subsidies to make the dollars and cents work?
just like to repeat that. Viability of wind farms today.
Well, living in British Columbia, we kind of live in a bubble. We have enjoyed extraordinarily low electricity prices ever since the large hydroelectric dams were installed in the 50s, 60s, early 70s. And it's simply one of the unpleasant facts of life that new generation costs more to install than what we are accustomed to paying. There's two other considerations to this. One is that technologies such as wind generation does not require fuel. And so without needing fuel, you aren't faced with the commodity risk or volatility of fuel prices, which go with any type of fuel-consuming generation. The second major consideration is that wind power is not trashing our atmosphere the way many types of fuel-consuming generation modes are doing. As a society, we haven't yet put a price on that. It's one of the great debates of the energy industry right now. But, you know, I think with the consideration that in North America that 1 out of every 4 visits to the emergency room is due to child asthma, and with the observation that surveys of waterways in North America have shown 100% contamination by mercury, which is a consequence of coal-generated electricity, let alone the greenhouse gases, that these are prices to our quality of life which have to be considered. Going beyond that, though, there are many countries in the world which have adopted wind power as a viable means of generation. China's a prime example. China has plans right now over the next 7 years to be putting in 150,000 megawatts of wind power. That's 10 times the generation capacity of British Columbia. So they would not be doing it if they had not done a very, very careful analysis weighing out what the long-term costs are versus the other choices that are available.
Yeah, I'll just add a bit to that real quick. Firstly, costs for wind are coming down. They've been coming down consistently at technological advances, economies of scale. I saw a graph once that showed a bit of a blip. As I mentioned, 2008, things got really hot. But the study I heard and that I believe is that the increase in price was not due to an actual increase in production cost. It was simply the demand, the insatiable demand for those turbines from those top 5 companies that were tried and tested. Post-crash, that's gone. Prices are still dropping. In the last call, we were competitive. I mean, for all the reasons, the cost reasons, the other reasons, BC Hydro picked our project and others. We bid against other sources of fuel. Open choice for fuel. The only rule, BC Hydro's rule, I think was no nuclear. But beyond that, the only rule was that overall you couldn't emit. So in that context, we were competitive. But the other piece I want to mention is the idea of hidden subsidies. And they're all over and they're hard to see. So our project has, wind in BC today has very few explicit supporting subsidies. What we don't have is, if you look at the big industries of forestry, mining, oil and gas, say the R&D dollars that go into training up the people and developing the technologies. I know there's a wind tech program at Northern Lights College up in the Peace region. So we're talking about something at North Island College here, and I've had the privilege of teaching a wind development class at BCIT last couple of years. I can tell you that the R&D dollars going into that is nothing compared to what it is for some other industries. And then you get in, it's all over the map, and it's always sort of hidden. In permitting, just the inefficiency and the amount of steps that we have to go through for a wind farm compared to the more streamlined process for some of these other industries that bring a lot more certainty. All these things add to the cost. So part of what we've been striving for, and it may or may not be achievable, but we'd like to approximate something like a level playing field before we can really look at that true comparison of cost.
One second, I'm just going to check with Ellen and see if we have covered everything online. Any questions that are unique to?
No.
No? Okay, great. 2 more questions, and I think we're going to have to close in. Sorry. Sir, I think your hand was up first.
Just curious about how consistent is this Ipscott wind farm? Because wind, do we have peak time or downtime, sometimes no wind, that kind of stuff? And how do you forecast in the useful lifespan? I know climate is changing, that kind of stuff. Does it affect the wind in that site? And how do you forecast how the wind is going to be in the next, say, 20 years? Will the wind die off? And there's some better time of the year or lower time of the year, that kind of stuff?
If I can just paraphrase that for the audience online. Just a general overview of how you go about judging the wind strength and the viability of the wind strength over the course of the year.
Yeah, really good question. So first of all, I'll just address the standard way of doing business in the wind industry. Rule of thumb, you need 12 months of wind data on your site. That gives you the seasonal profile. And as Paul showed these graphs, in BC, wind tends to blow harder in the winter, so we have more energy in the winter, less in the summer. We build up that profile. We know that that happens to match our demand. So, month for month, that's great. There's always going to be variability day to day. So yes, there's absolutely times when the wind farm is at full production. There's times when it's at zero production. And furthermore, wind year over year tends to vary roughly, as a rule of thumb, 10%. And that's not a whole lot. I mean, hydro varies more than that. So, you gather data on the site. We built it out, to look at the spatial variability. We had 8 years of data, so we had a very good understanding of the wind there on the site. And BC Hydro, through their ability to move power around through transmission, their ability to store it and quickly ramp up and down hydro dams, that's a capability they already have. They can integrate that. And there are limits to how much renewables can be integrated in the system, but very few utilities are approaching those limits. So that's all included in their economic analysis. And at the end of the day, our project is paid per unit of energy. And it's actually paid slightly more for energy that's delivered in the peak times of need compared to the other times. So we work all that into our model, and the owner of the project takes on some of that risk. So that's a more straightforward answer. Your difficult question about what climate change will do to winds, we don't know. My feeling is it will make winds stronger. Could it conspire against us to make winds not stronger in that spot? Possibly. But I think hopefully winds will stay at least consistent, and we're also trying to combat climate change with this. So time will tell on that one. Do you have anything to add to that, Paul? Okay, thank you.
Final question, sir.
About 15 years. About 15 years ago, I was working on the naval base as a base development engineer, and BC Hydro approached the base to experiment with what they called Aeolus turbine, wind turbine, which was essentially looked like something like a egg beater, because it was a vertical cylinder that rotated with a vertical axis. Why they approached us was that they experimented with wind turbines of the conventional design on mountain tops up in the Kootenays, I believe, and they found that hunters kept shooting at them and the blades and damaged them. So they wanted a safe place to experiment with the Aeolus turbine. And so I made arrangements. This was approved by the base, and we put it within the fenced area of the naval magazine out here at beyond Pedder Bay, where it would be safe from hunters and other people. And the experiment was finished, and they took the thing away. About 3 or 4 years ago, I was attending a presentation by a woman who is head of the BC transmission group of BC Hydro, and I said, what became of the Aeolus turbine? And she'd never heard of it. Now, there must be some information on it, which might have some value to your organization. Also, I think that it would be less harmful to birds because of its design.
Thank you. And that vertical axis, I mean, that is a type of design, as I mentioned, that different types of designs were tested. I'm going to invite Paul, after I've made my comment, to talk about vertical axis, because I know he's still looking at it a little bit, and it still is used for smaller applications. But part of the reason that this Danish design won out for large turbines is that machines are striving to get higher and higher into the higher wind speeds, the cleaner winds. We're installing an 80-meter tower. I mean, today they're approaching 100 meters, some 120-meter towers, and really trying to get that whole rotor up there. So that's a bit of a guess as to why that machine works better than the vertical axis, which gets broader as it goes down. But for all factors in, that Danish design has proven to be the most economic. Shooting at them is definitely bad. The blades are made of fiberglass that won't do very well. Every wind turbine that's in and around Hunting has to consider that. With all respect to the military, I'd never considered moving a turbine closer to the army so it wouldn't get shot at. That's a neat idea. For sure. And with respect to birds, I don't know that there's. I mean, all the data, all the large wind farms now are being done with that Danish design. Paul, you more familiar with vertical axis?
I don't know that I'm really familiar with them, but we are studying. We have been doing a survey over the last couple of months of what's out there, largely because we have an interest in working with remote communities to help them transition from reliance on diesel for their generation to locally available renewable resources. And for a variety of reasons, I believe that smaller vertical access machines are a big part of the possible answer. But there's another less intuitive answer to this, and I just want to mention it briefly because I think it sheds a great deal of light just on one aspect of the industry, which is that a large multi-million-dollar project will never get built without a warranty on the equipment. And so it doesn't matter how good a technology seems. I guess the point that I want to make is that there are so many moving parts in a project such as the one that we've developed, which have to be accepted by so many people, each aspect of it. And in the case that I've just put out, having a warranty and going through testing and rigorous review and having bankers get comfortable with the technology and developing track records and so on is just one aspect. And I believe that the three-bladed upwind design that the Danes really brought to commercial maturity will likely be superseded sometime in the next decade or two by some other new design. But the reason that they were successful with this, I think, is in large part because they reached that warrantability for the equipment. So.
Supplement this. Some years ago, the Quebec Hydroelectric Commission did some extensive research and study on this type of wind generator, and they eventually dropped it for a number of reasons. That might be a place to look at to see why. And the city of Reno has installed 9 or 8 or 9 different models of wind turbines in the city to check them out. Have you seen anything, looked into that to see what they're using?
Yeah,
might be interesting to look at.
Yeah, it would be, and I think it's a wonderful trend for municipalities to be looking at bylaw changes which allow local generation of this sort. And it's quite likely that cities will be encouraging vertical access machines, I think.
Real quick on that, I know vertical access can handle turbulence. They're often a more suitable machine to put on top of a building. And that's great. It's great to be looking at wind energy, integrating it into our landscapes, offsetting the power consumption. But just to be clear, with wind today, if you're trying to do anything other than a large utility scale project in a suitable spot, don't expect it to be anywhere near as economic as a large wind farm. That's just how it is today. Yeah, they're market leader for sure.
Okay, ladies and gentlemen, I think we're going to have to close it there. Thank you to those online. James, Paul, thank you so much. Before we go, thank you, everybody. Round of applause for Paul and James. I'd like to now bring Elmer Sum up as we're going to present our speakers a token gift.
Thank you. Things that I learned from some very wise manager in my career is that the CEO and so on, they judge not only by the shareholder value, but how well they pick those that work for them. I think you will agree with me that James is a shining example of this university can produce. So let's give James as well. So we have two wise men up here, and the future is very bright for this particular project. Now, talking about university usually low budget in terms of gifts. We hope to change that in the future, but for the time being, we will just have a token of appreciation for these two wonderful speakers that provide us with so much insight. I think I would like you all to join me to give them a big hand in, okay. James and Paul. Thank you.
Hello. Well, that wraps things up. A big thank you to Charles Kriskoff from Royal Roads again, to our event sponsor, HSBC, of course, and all the other sponsors as well. We would encourage networking. And Elmer, you may have an event coming up in February.
In February, we will be very fortunate to have a very senior executive from the mining industry, one of the key revenue and job creation engine in the province, to share with us the mining industry's insight into green and clean and renewable energy. He's not only a senior executive at TECK, but also very active in the mining association across the board. So we would be very interested to hear Dr. John Thompson's insight into how the mining industry's perspective going forward on the green and clean technology area. Thank you very much, Tom. Okay. Please, one more thing. I would be remiss if I do not introduce Alan, and please come up here, don't be shy. Alan is a very good example of what Simon Fraser can generate. And Dorothy is a very shining example of what UBC is. And I already commented on the great graduates of Royal Roads University. So Charles, I already paid that debt. And so please join me in thanking these two ladies who's put this together. And also, there are a lot of great University of Victoria volunteers that help us today. So please also join me in thanking the University of Victoria contribution in this particular event. And promotion college. My apologies. By all means, and likely the next event will be rotating around the island, so likely we will have the good fortune of having this event in other locations such as Camosun College and others. So thank you very much for joining us. Thank you.
Thank you.